Hope that you are doing good. So, today I will try to track um, this kind of motion. I will try to show you this motion, which is moving the object up and then stop and then returning back to the ground. So, what I will do here, I will start by having the video. So, I will import a video right here. Let's see. So it's not right here, it should be right here. Yeah, so this is the video. I will add this video right here, guys. So I will try to start the video so we can catch um, like certain portion from this video that can work very well with us. So let's do that, guys. That doesn't work. This one is very good. So we'll go back a little bit. I will go back a little bit. I need the time when the ball leaves my hand. Yeah, right here. And what I will do, I will try to have this. So go a little bit here. Yeah, adjust everything. Okay, so this is very good. And now I will adjust this one and bring it right here. So it needs to be exactly right here. Nice. So now we have good portion that can help us from this video. This is what I'm looking for. This is what I'm looking for, guys. Yeah. So now, what I will do, I will try to track this ball's movement, and to do that, I will start with the sitting scale. So how can I do that? I will, yeah, I need to have my scale to be right here. Exactly. It's not clear if the ball is. Yeah, I don't have very good camera, and that's why. So I will try to have, yeah, my origin right here. So this axis right here is y-axis and it is positive. This axis here is x-axis and it is positive as well. And we are interested in y-axis, of course, because we know that this ball will go up and then return back along y-axis. So now what I will do here, I will set scale. So I will do that. So let's do this. Yeah, calibrate stick. So I have this. I will try to change the color. Okay, yeah, here is the color. Yeah, so we can change the color maybe to have something a little bit white. Yes. So now I will set a scale. Here I have meter. So the distance here is 1 meter, exactly 1 meter, guys. So we'll try to have it exactly 1 meter. Yeah, so this is exactly 1 meter, guys. Great. So we have everything set. And now what do I need to do now? I need to track this ball and see the position versus time and the velocity versus time plot. So let's do that together. And maybe I can do something here. I need to go to track. I don't care about the mass, so it's not important. Yeah, to have a mass. So let's assume the ball is 1 kilogram. So that doesn't mean anything because even with heavy masses, we will have the same behavior. So let's do that now and see what will happen. Okay, I will try to have very nice plots right here for you guys so you can see everything. I will have here y. Let's do that. So y position, and here we need to have vy, which is the velocity. Let's see, and here we have time. Yeah, so y versus time, position versus time, and velocity versus time. That's great. And now I think I can track the ball by doing this. So I will move like this, guys, and follow the ball movement. See what will happen and what kind of behavior do we have. Okay, you can see that the position versus time started to be nice and wonderful here. I will go down and we'll go down, continue to go down. That's great. So now you can see this. You can see this behavior. So this is a very nice behavior, guys. I think I will try to do that. Yeah, I can't adjust it, so let's keep it like this. But you can see the behavior in general. So here's the velocity versus time. And I will show you the acceleration also versus time. So the acceleration versus time here is negative, and it is around minus 9.8 meter per second squared. So that's very good, and I will try to figure out the acceleration by fitting the velocity versus time plot. So how can I do that? So I will try to go right here. Yeah, before I do the fitting, I can show you this, guys. So you can see that we can see the trajectory of this. Yeah, of this. So here's the turning point. The turning point is somewhere right here. Yeah. So this is the turning point, as you can see right here. Yeah. So I will try to do that. Okay, yeah. Yeah. But now, let's try to fit this with the line. So what I will do, I will try to do analyze again. Okay. Analyze, curve, line. Yeah, so that, oh, great. Yeah, great. So now I could manage to have yeah, the accelerations, as you can see, guys, right here. So I could manage to exclude this point that you can see right here. So what we have the acceleration is minus 9.967 meter per second squared. So that's great. So now the acceleration is negative for the whole behavior, and this is what I what I want to show you guys. So the acceleration is negative along the whole process. Now, since we have that, and also we can see the initial velocity. Yeah, the initial velocity is 4.949 meter per second. Also, we know the initial velocity. So the initial velocity, as you can see right here, is 4.94 meter per second. Yeah, and here you can see the equation that we used. So V is equal to A constant times T time plus B constant. Okay, so yeah, so that's great, guys. We could manage to figure out the gravitational acceleration using this simple way. And what I will do right now, guys, I will try to change the coordinate system. And what I will do, I will try to rotate the coordinate system. And we will see what will happen. So what does that mean? That means the positive y-axis will be down and the negative y-axis will be up. And we will see what will happen, guys. And we will see what will happen. So I will show you that. Just I will reverse the axis. I will rotate it like this. So I will try, yeah, to rotate everything to that. Oh, yeah, that's great. That works very, very well. So I rotated the axis, and now I will come here and see what do we have. So analyze, yes. So, okay. I think we have the gravitational acceleration now. Yes, I could manage to do that. Perfect. So you can see after we rotated the whole system, so up we have positive, negative y-axis, and down we have positive y-axis. And in this case, the gravitational acceleration can be positive. But if I rotated the axis again and have positive axis up and positive y-axis up and negative y-axis down, so we will have negative 9.96 meter per second squared. So here you can see that we have negative velocity and positive acceleration. Yeah, that's great. And also I can show you here the accelerations. So maybe I can try to go to the acceleration. So the acceleration is positive, and it is around 10 meter per second squared. So yeah, that's great, guys. So as you can see here, we could manage to know the acceleration in the gravitational acceleration sign. What do I mean by the sign here? I'm talking about a positive or negative sign. So if we have the positive side of y-axis up and the negative side of y-axis down, so we'll have positive gravity or positive g, like positive 9.8 meter per second squared. If we have, yeah, it should be negative. If we have positive, if the positive side of y-axis is up and the negative side of y-axis is down, so we will have a negative sign in front of the gravitational acceleration. If the negative side of y-axis up and the positive side of y-axis down, so that will give me positive gravitational acceleration, as I showed you guys. So this is a good thing that can tells us that the gravitational acceleration will stay positive, for example, like this, through the whole trip for the ball. If we rotated the axis again, if we rotated the axis again and go like this, for example, so we will notice that the gravitational acceleration is negative. So maybe I can show you this right here. So we have negative now, negative 9.96 meter per second squared. Yeah, and this acceleration will stay to be constant throughout the whole trip of this ball. So what does that mean, guys? That means we will continue to use negative sign if we consider the positive side of x-axis of y-axis up and the negative side of y-axis down. And this is a good thing, guys. I couldn't tell you to follow just signs and explain this in the session without proving that to you experimentally. So when we did that experimentally, guys, now you will have confidence when you start working with equations of motion and you are 100% sure that if the positive side of y-axis up, that means I have negative gravitational acceleration. If I rotated the axis and considered the positive side of y-axis down as I did, so you will have positive gravitational acceleration, as you can see here. Yeah, positive 9.96. Okay, so that's great, guys. I'm happy to show you that, and I'm happy that you learned this experimentally. So we will continue talking about projectile now, since we jumped over this, and now you understand that the gravitational acceleration will continue to have the same sign throughout the whole process. Thank you so much, and see you next session. Thank you, guys.